Welcome back. In this video, we're going to continue learning about matter and measurement. Specifically, we're going to focus on determining the number of significant figures within a measurement and including values expressed as scientific notation, and then correctly use significant figures when performing addition, subtraction, multiplication, and division within measured values. So a measurement consists of two parts. There's the number and there's the unit that accompanies that number. For example, you might measure on a scale a mass reported in grams, and you might get 10 grams. The number is 10, the unit is grams. The number tells us how many or how much of that substance, and the unit tells us the scale of the measurement. Measured values, however, contain error. There's fluctuations within anything that we measure, and therefore we need to report how precise those measurements are, and significant figures are the way to report those values. Now, what are the rules for determining significant figures? There are three rules. The rules are that all non-zero numbers expressed are significant. All zeros that are held between non-zero numbers are significant. And all zeros to the right of a decimal and a non-zero number are significant. So let's go through a couple examples. The number 2,843.2 has 5 significant figures or 5 significant digits. The reason for this is because it contains 5 non-zero numbers. The number 2,843.20 contains 6 significant figures. And this is because it has 5 non-zero numbers and a 0 that is to the right of the decimal and right of a non-zero number. However, 0.20 only has 2 significant digits. It only has 1 non-zero number and 1 0 that's to the right of a decimal and a non-zero number. The one to the left is not significant. Let's see if you can figure out the number of significant digits in these 3 numbers. Pause the video and try to determine it. Welcome back. Let's see if you got the correct answer. We have 4 significant digits in the first, 3 in the third, in the next, and then 4 in the fourth. In this first number, 10.20, the 1 and the 2 must be significant. Therefore, the 0 between them must also be significant, as it is between 2 non-zero numbers. The 0 on the right is also significant because it falls to the right of a decimal and to the right of a non-zero number. In 1020, there are only 3 significant digits. The 0 in the middle is significant because it's between 2 non-zero numbers. However, the 0 on the right is not either to the right of a decimal nor between 2 non-zero numbers. If we wanted to express 1020 to 4 significant to 4 digits, then we would put a period at the end of that and get 10,020 period. Now, let's talk about scientific notation. Scientific notation is where we take a number, we write the number times 10 to some exponent. What that number indicates then is we've got 1 times a million, or times 10 to the 6. This number only has 1 significant figure, and it's just based on the part, the number prior to the exponent, or prior to the scientific notation. If we had 1.0 times 10 to the 6, that has 2 significant digits. And we can follow the same rules that we saw here highlighted in blue. So the modifier times 10 to the 6 just tells us that we're talking about millions. So we have 1 million or 1.0 million. Why don't you practice on these 2 numbers and see if you can figure out the number of significant figures here. Did you get 1 and 3? I sure hope so. The reason why there's only one significant digit in this number is because the 0, while after a non-zero number, it's not after a decimal and a non-zero number. These 3 digits here are significant because they follow, they are to they're sandwiched between, in the case of this digit on the right, it is after a decimal and after a non-zero number, which is the 1 here. And the 0 in between is sandwiched in between two different significant figures. Let's now talk about doing operations with significant figures. If you're doing multiplication and division, there is one rule, and addition and subtraction has a different rule. So for multiplication and division, the number that's involved in the calculation that has the fewest significant figures will determine the number of significant figures in the answer. For example, 1.045 times 12.1, we have 4 significant figures on the left and 3 in the number on the right. So multiplying this out, you would get 12.6445, but we need to round to the proper number of significant figures. The number of significant figures on the left, again, is 4. We have 1 for each of the non-zero numbers, and then the 0 sandwiched in between is significant. On the right, we have 3 non-zero numbers. So our final answer must also have 3 significant figures. That would get us 12.6. For addition and subtraction, the least precise value involved in the calculation determines where we round our answer. And that's based on the placement of the numbers. So if we have 12.3 plus 640, this would get us 652.3. The last significant figure, the one that's least precise in 12.3, is in the 10th place, the value indicated here, the 3. In 640, our least, the last precise value is in the tens place, the 4 of 640. That means that our answer must also be rounded to the tens place. So if we round 652.3 to the nearest 10, we get 650. All right, let's have you practice a problem here. We want you to round the following answer to the correct number of significant figures. Pause the video and try this on your own. Welcome back. So we're giving you here the final answer in terms of its numerical value, and you must round it to the proper number of significant figures. How do we do this? We should first perform the steps inside the parentheses. So we have 180 plus 53. That gets us 233. If we evaluate this, we use the rules for addition and subtraction, which is that we evaluate the least precise value in each number. And in 180, the last significant digit is in the tens place, and it's in the ones place in 53. So the 8 in 180 is significant, the 3 in 53 is significant. So if we were to round this answer at this point, we would round it to the nearest 10. However, since it's not the final answer, we actually want to keep the number 233 as we continue on. So when we complete the division operation, we actually use the number 233 instead of 230. So we take 233, divide by 63.1, we get 3.692552. The least number of significant figures would be 2 due to the 230. And because there's 3 digits there, our final answer should have 2 significant figures, and the final answer is 3.7. So while we use each operation, addition, subtraction, multiplication, or division, to determine the proper number of significant figures, be sure that you only round at the very end. That's it for this video. Thanks for watching and have a great day.